All right, now let's do the rules of derivative, but dealing with fractions. There's basically two types of fractions. All right, the first one, here's an example. I've got y equals to, let's say I've got x to the power of 100 minus 10 x to the power of 2 plus 7 x to the power of 3. And then we divide that by, let's say, by x to the power of, let's make it 5. Now, type number 1. Here at the bottom here, you are going to have what I call one term. There is one term. In other words, it's just x to the 5. It's not x to the 5 plus 3 plus minus plus. No. It's just one thingy. No pluses, no minus. You're going to get those type. Now, when you're having this type, it's easy to deal with them. So first, you copy what's at the top. You individualize. You individualize them. So each term at the top, separate them. Each one must be divided by that term. It's the same as doing this. X to the 5. Well, there is another way of just bring it here and write it as x to the minus 5. But I don't want to do that. You just do that. Each term must have x to the power of 5 f its division. So you're making it nice first. Then, to simplify it, you're going to say the top minus the bottom exponent, isn't it? 100 minus what? The 5, isn't it? Yeah. So now you're left with x to the power of 95 minus 10 to the, now you're having 2 minus 5. It's minus 3, isn't it? So it's negative 3. And then plus 7 x to the 3 minus 5, it's negative 2. There we go. Now you're ready to derive. Now let's derive now. Now you have dy all over the dx equals to, we now know this one is now easy. It's 95x to the power of 94 plus 30 to the power of negative 4 minus 14 x to the power of negative 3. Right, now that we understood this, but the exponents were not fraction or square roots. Square roots, it's fraction exponent. You need to know that. So if I give you x and I make it the root of 5, this is a way of saying the exponents are fractions, because you'll convert that to x to the power of 1 over the 5. So square roots, cube roots, radical sign or surds and exponents, powers are one and the same thing. All right, so let's give an example with something like that. So what if now I have been given y equals to the cube root of x minus the fifth root of x squared, and then plus x to the power of 7 over the 4, then divided by, let's say, the square root of x. Again, this type, it's the same as this one. One term at the bottom. It's one term. Can you see that? You need to split it. But first, change the fractions, change it to the fractional exponents. Isn't it right? All right. So the first one becomes x to the power of 1 over the 3, and then minus x to the power of 2 over the 5, plus, that one has already been changed, It's x to the power of 7 over the 4. We good, ne? The one at the bottom is x to the half. Like I said, when it's one term, separate them. So we're doing that. Already we're doing it one time. Then I'm going to put it here as x to the power of half. The thing is, you don't enjoy working with fractions. You don't hate them, you just don't like them. They're not enjoyable. It's 1 over the 2. And then we do exactly what we did, top minus bottom, the exponents, isn't it right? All right. So now we have this as 1 over the 3 minus the half. So when you take a third minus a half, you get minus 1 over the 6. 2/5 minus a half, you get negative 1 over the 10. 7/4 minus a half, you get 5/4. All right. Now you are ready to derive. Now you can now write dy all over dx equals to, when I bring this one in front, it will be negative 1 over the 6 times x. Remember, you're going to minus the 1 there, isn't it right? So it's going to be, I believe it's minus 7 over the 6. Just double check me. Minus 1 over the 10 times that one. It will be positive 1 over the 10 times by x. So it's minus 1 over the 10 minus that one. I believe it's minus 11 over the 10. Double check me. And then 5 over the 4 times the 1 there, the invisible one. It's 5 over the 4. And then x to the power of, you're going to minus a 1 there. I believe it will be 1 over the 4. You left this with exponents which are negative. You can change them and make them positive. I'm going to keep on doing that. So you're going to have a negative 1 all over the 6. Only what has the power goes to the bottom and its power changes. We good, ne? Don't change that minus there. Don't. It's wrong. So the box is the one that goes down and changes the sign. Then it becomes 7 over the 6 there. And then we now have plus 1 all over the 10. And that one becomes x to the 11 over the 10. And then plus 5 all over the 4. And then this becomes x to the 1 over the 4. Well, you can also write it and say equals to, it's negative 1 all over the 6. If you want to use radical, since it's 6 here, it will be the 6th root of x to the 7, and then plus 1 all over the 10. You're working with the 10th root. The 10th root, okay, I need to make it look good, that one. It will be 10th root of x is to the 11, and then plus 5 all over the 4, the 4th root, yeah, of x to the 1, or just x. You can leave it here or there or there. Leave it with positive exponents or with radical, only if they ask you to do that. So that was type number 1. We're going to go to type number 2 in the next video, and everything will be done.